And our first solution was at 4 plus, and now we have to do the fourth root. To do the fourth root, we're going to have to use some parentheses. To do the fourth root, we're going to have to put in 9. And just briefly, how do you put in the fourth root? Good question. Let's go back real quick to the DocCam. To review again, if you have, let's just go for the bth root of x to the a power. Reminder, that's x to the power of a over b. Going back to our example that we had up here, we had the fourth root of 9. So how would we rewrite that? We'd write that as 9 to the 1/4 power. Use that, let's go back to calculator and throw that puppy in. So we have 4 plus 9 to the 1/4 power. Now, a question students are always going to ask, could we put in 0.25 instead of 1/4? Absolutely. Hit enter, what do we got? And we got 5.73. Now, let's check just that first solution. Let's check it for reasonableness real quick. Let's go back to the table. On our table, we see we were estimating a solution between 5 and 6. 5.73 between 5 and 6. There's a good reasonableness check for us. Oops. Let's do one more. Let's do 4. We also have to do 4 minus because there are 2 solutions. So let's go 4, subtract, and again we want to take 9 to the 1/4 power. Oops. Yeah, there we go. Go 1. And we got a solution of 2.26, and actually 2.27 once we round up. Let's go back to the table again, just reinforce or check for reasonableness of our solution. We were estimating a solution between 2 and 3. 2.27 fits that, so we're good to go. So again, go back, our 2 solutions. And x is approximately 5.73. Or second solution, x is approximately 2.27. Okay, again, instructor, opportunity to pause, opportunity to go on. There are a lot of different types of problems in this section. If at any point you want to pause, do another example, or do a like problem, feel free. Definitely a section that you got to check for understanding as we're going through, because there is a lot that's covered in this section. So again, instructors, go ahead and pause for a second if you need to. And let's go on. Factoring. Another type of function that we're going to run into today is one that we have to solve by factoring. And again, you've probably factored the numbers that multiply to the last, that add to the middle term. With this one, we're going to run into some situations that might not immediately appear like they're going to be factored. However, factoring will give us the easy solution, or the easy way to get our solution out for that. Let's learn by example, so let's take a look for just a second. We want to, for each one of these, in fact, for the rest of the section today, we want to find all the real solutions. Our first one we're going to take a look at, and we have 3x to the 4th minus 12x to the 3rd minus 21x squared is equal to 0. Now, just to make the instructor aware, the examples that I chose are significantly more difficult than the ones in the book. If you feel like you need to scaffold that up to your student's level, feel free to just take that earlier example, of that easier example that's in the book. Go ahead and run with that one. This one has a couple more steps to it than the one in the book does, just so we can cover 2 or 3 things within one problem. Good part about this one, it's equal to 0, b equal to 0, we can use zero product property. Bad news for this one, we got all sorts of junk on the other side. With my students, I always tell them first thing, take out everything that every term has in common. So as you're looking through this problem, you're looking through the terms in this, what do they have in common? They definitely all are factors of 3, so we can take a 3 out. What else do they have in common? They also have an x squared at least. Once we take that out, what do we have left over? Take out a 3x squared, you're just left with an x squared. Again, if you want to check that, this times this has to equal our original step. Take out a 3x squared, left with a negative 4x. Take out a 3x squared, you're left with just a minus 7. Again, if you want to check your work, multiply out. You should get your original term back. And I screwed up, so I got to take a pause for a second. What did I not copyright? 7 doesn't factor in 4 and 3s. What's my original problem?
Almost 3x squared, x squared minus
6 doesn't. What was I thinking? Took 3. 3 times 7 gave me 21. What was I thinking? 7 doesn't. 7's only 1 and 6.
Did you write it down wrong?
Yeah. I did all my problems, and I just wrote out what I wanted to go through. 21, so that 4.
So figure it out, and I'll
Okay.
do my best to remember to edit this section.
Okay. 21, 3. What I wanted to go? I wanted to go to 4, negative 4. 8. 8's no, that's 2 and 4. 6, 1 and 5. Yeah, that's what that must be an 18. Okay. Better make sure that works out. I don't want to be a dork twice. 8. Take a 3x squared, 6. Now 18 doesn't get her. I want to go to 4. Come on, Jeremy. 6 and 2 is 12. That's too tough, though. Oh. Yeah. Oops. Okay, start over with that example again. I'm ready whenever you are. Okay. So in this section, we're going to take a look at factoring again, and we're going to find all real solutions. So first example, let's go 3x to the 4th minus 12x cubed. Now let's go minus 15x squared. Now, if my students, I always tell them, first thing you get a problem, it's equal to 0, you get to use the zero product property. With that, take out anything they have in common. When looking at all three of these, what do they all have in common? They definitely all are factors of 3. What else do they have in common? They all definitely have an x squared. Once you take that out, what's left over? You get an x squared, you get a minus 4x, you get a minus 5, equal to 0. Again, if you want to check your work on this, multiply back on through. You get your original problem out. This is the nice part. We're just going to leave it alone for right now. Take everything else, what's inside. How can we factor that? What multiplies to negative 5 and adds to negative 4? Well, that'll be x plus 1, x minus 5. Then what solutions do we get out using the zero product property? Well, if 3x squared is equal to 0, x plus 1 is equal to 0, x minus 5 is equal to 0. Solve that, x equals 0, minus 1 to both sides, x equal to negative 1. Add 5 to both sides, x equal to 5. So our 3 solutions for this are what can x equal? X can equal 0, or x can equal negative 1, or x can equal 5. Plug any of those into the original problem, we'll get 0 out, have both sides equal. Again, there are several different types of problems in this section. With that, if you needed to stop and do one over, or if students feel like they need another example like that, feel free to pause the video and move on to the next one. Next example in this section of advanced factoring, or problems that you use factoring that might not immediately appear. We have the second type, x to the 4th plus 6x squared plus 8 is equal to 0. Now, instantly students are going to say, if this one, an x to the fourth power, you can't factor that. Well, take a look at this. You got x to the fourth power, you got x squared. The question I ask my students, okay, what don't you like about this problem? They're going to say, I don't like the fourth power in that. Let's think of a way we can get rid of it. And what this involves is the first probably new method that you're learning today, or new solution, and that's using a t substitution. Now, I've heard this called every letter in front of substitution you could imagine. When I was going to college, it was a U substitution. In our Cohen book, it's a T substitution. In the Algebra 2 book that the state uses for the high schools, it's called an X substitution. What we're going to do is we're going to figure out what can I use to get rid of what I don't want. And what I don't want is x to the fourth power. That's what I want to get rid of. However, what I want to look at is this. What if I substituted t for x squared? Now, question to you guys. What would I have to do to x squared to get to x to the fourth? Well, with that, I have to do that same thing to t. What do I have to do to t to get to the x to the fourth? I'd have to square t also. So if I square both sides, x squared gives me x to the fourth, t squared gives me, t squared gives me t squared. Let's use that and substitute that back in. Once we get that, look what we get here. We get t squared plus 6t plus 8 is equal to 0. Bang, look at that. Take it from something that looks, I don't know what to do, I don't know what to solve. Now, look at this, looks familiar. Now, there's a caveat at the end, there's a catch, so don't get too excited. With this, something we can factor it into t plus 4 times t plus 2 is equal to 0. I'll assume that you know how to solve that. Our two solutions that we get out, t plus 4 equals 0, t plus 2 equals 0. Minus 4 from both sides, minus 2 from both sides, so we get t is equal to negative 4. This one we get t is equal to negative 2. Now, I'm not going to lie to you, 9 out of 10 students circle that, walk out the door, think they got the right answer. However, the original question was in terms of what? That's right, it's in terms of x. So we actually have to go back and ruin some people's day, go back to the original problem. We're not solving for t here, we're solving for x. That's what we want to get out. So plug that back in. We get an x squared is equal to negative 4. We get an x squared is equal to negative 2. Uh-oh, now we got problems. Take a square root of both sides. We have a square root of a negative, square root of a negative. And remember, we're looking for all real solutions. So even though 9 out of 10 people are going to walk out the door thinking they got it right there, this one has no real solutions. So this is one that most people walk out of the door thinking they got it right, unfortunately, and go back, look at it later, no go. Again, I'll pause just for a second if your instructor wants to work another one or wants to talk through that one. The next example we have, again, these are quadratic-like problems. They are definitely not quadratics in their original form, but we're going to turn them into something we can factor, turn them into something we can do something with. So the next one, let's take a look at example C. We want to again find all real solutions. We have 4x to the negative 2 plus 11x to the negative 1 minus 3 is equal to 0. Now, as with most problems in math, there's multiple ways to solve this one. There are multiple ways to solve the first two we talked about. We used factoring. With factoring, you can always use the quadratic formula. However, I tell my students it's almost always easier to factor. If you can factor, I would factor. In addition to that, if you remember how to complete the square from Algebra 2, sometimes that ends up being easier than using the quadratic formula, especially if you like to solve equations. That typically flows through easier. This one I'm going to use yet a different method. This method on this, I again ask my students, what don't you like? Well, they'd say, I don't like x to the negative 2 power. I probably don't like x to the first power either. So with this one, what we're going to do, what we're going to throw at it is we're going to multiply both sides by x to the negative 2. Now, as we're doing that, we have to check what would not work for this. What would not be a solution for this? And that's true. X can't equal 0. You can check that by going, if I plugged in 0, I'd have 0 plus 0 minus 3. Is that equal to 0? Nope. So it's okay to do for this one. With that, after I multiply it through, I'm left with 4, because x... Oh, darn it. I made another mistake.
I just need to keep track of what I need to have edited out.